Okay. So, as we normally take the approach with functions when we're first looking at them, we're going to talk about the domain and the range of this. And I think, you know, this is reviewed. You guys have seen this before, but it never hurts to just talk about it a little bit. If we were to graph this, first of all, an exponential function has a variable in the exponential level, right? It can have variables on the bottom, but it gets messy. But on the top, we have a variable, some combination or some transformation up there. If we plot a few of these points for x, just a handful. This first point, if we say y equals 2 to the negative second power, as a review of your exponent rules, when something has a negative exponent, I create a fraction. If there isn't already one, I create one, and then I move whatever that power is into the denominator. So 2 to the negative second power is 1 over 2 squared. Okay, a lot of manipulation with exponents like that in calculus, using negative exponents in denominators, and then also the opposite of that, taking a fraction and writing it with a negative exponent, because there's a lot of rules with derivatives where you need exponents. You don't want fractions. Okay, so be comfortable with this method. It comes up quite a bit. So we have for negative 2, we have a value of 1/4. For negative 1, we would have a value of 1/2. Anything raised to the 0 power is 1. 2 to the first power is 2, and 2 squared is 4. So I have these 5 points, and you start to see this pattern of, as the x values increase, the y values increase. As the x values decrease, we get fractions, right? But what won't we get? Negative numbers, right? So that tells us what our range is going to be, because even if the x values are negative, we're just taking the value and flipping it into the bottom, right, of a fraction. So we're moving it to the denominator. We're not making it negative when the exponents are negative. So we have when negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, and 2, 4. So when you look at the graph, graphically speaking, okay, for an exponential function, you see this asymptotic behavior as you move towards negative values of x. As the x values get more negative, all that happens is this power gets bigger in the denominator of a fraction, and you have a 1 on the top. So you have 1 over something really big. That's a fraction that's really small, but it'll never be 0. Why won't it be 0? Why can this exponential function not be 0? Because if it's a fraction, the numerator is 1, and when is a fraction equal to 0? If the numerator is equal to 0. The only way a fraction can have a value, have no value, in other words, the only way a fraction can have no value or a value of 0 is if the numerator is 0. So that's why we see this horizontal asymptote where y equals 0. We're never going to cross that line. This function's never going to have that 0 value, because we'll always have a 1 in the numerator when we flip this into the bottom. That's why we get that horizontal asymptote. That horizontal asymptote is going to become a little bit more important when we look at logarithms here in a minute. So the domain, right? We ask ourselves what with domain? What do we ask ourselves?
What can't happen?
What can't happen, right? And we're talking about fractions, and we're talking about radicals. Do you see any fractions? No. Do you see any radicals? No. So the domain is infinite for an exponential function. From negative infinity to positive infinity. The range is, in this case, only positive values of y. From 0 to infinity. Notice the parenthesis with the 0, not a bracket. The bracket is inclusive, which means we could get a value of 0. That's not going to happen, right? We have a horizontal asymptote. We have a horizontal asymptote of y equals 0, and we have a y-intercept at 0, 1. Those are sort of the defining characteristics of exponential functions. Okay. When we look at, on the next slide here, we're going to look at a transformation of an exponential function. These are going to change, some of them, right? Any questions about exponential functions in general? Okay. We don't focus too much on this. In pre-calc, there's some discussion about exponential growth. There's some discussion about interest, compounded interest, okay, which, quite frankly, if you want to really get into that, go into accounting, right? That's my philosophy on it. Nobody earns money in the bank anyway. It's a crooked industry.